We're going to start triangle trig today. This is really just a review from what you saw in geometry. A trig function is written as a ratio. If you'll look right here, the sine of theta is written as opposite over hypotenuse. And this here you should remember as theta. You probably talked about that in geometry. Remember that sine is the opposite over hypotenuse. You probably remember sine, cosine, and tangent. Some of you say SOHCAHTOA, and some of you remember the phrase, some old hippie caught another hippie tripping on acid. And so that's how you remember your sine, cosine, and tangent. But the sine of theta is the opposite side over the hypotenuse of a triangle. And the opposite side, find your angle theta, and the side opposite that angle is your opposite. The adjacent side is the side that touches the angle. Now notice your hypotenuse touches one side, but it is the leg, the adjacent side is the leg that touches your angle theta. So sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, tangent of theta is opposite over adjacent. Now if you'll notice, there's three here that you probably don't recognize. These three here, this is called cosecant. The way this is written, it's cosecant of theta. That's C-O, cosecant. And then secant of theta. And then this is cotangent of theta. So the cosecant of theta is CSC. This is the reciprocal. You've got cosecant of theta, secant of theta, and cotangent of theta. These are the reciprocal functions of sine, cosine, and tangent. So the cosecant of theta, if you'll notice, it's the hypotenuse over opposite. It's just the flip of your sine. It's the reciprocal. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. And the way I remember which word goes with the three trig functions that you're familiar with, if you'll notice, you've got sine, cosine, tangent. Of course, cotangent is the reciprocal of tangent, so that one's not hard to remember. And I remember the reciprocal of sine is the other C word. The C's and S's go together. So the reciprocal of sine is cosecant. The reciprocal of cosine is the other S word. It's the secant. So you've got sine, cosine, tangent, cosecant, secant, and cotangent. So in example 1, it says find the value of the sine, cosine, and tangent functions for theta. Well, we're going to find sine, cosine, tangent, cosecant, secant, and cotangent. So the sine, I want you to pause the video and I want you to go through and do your 6 trig functions. So also find the cosecant of theta, the secant of theta, and the tangent, the cotangent of theta. So you pause the video and go find those 6 ratios and see if you get them right. So the sine of theta is opposite over hypotenuse, so 7 over 25. The cosine of theta is adjacent over hypotenuse, so 24 over 25. Tangent of theta is opposite over adjacent, so 7 over 24. Cosecant of theta, and I don't memorize these 3 here. I just know that cosecant is the reciprocal of sine, so you can come over here and you can say, okay, if sine is 7 over 25, then cosecant is its reciprocal, 25 over 7. The only problem with you just going over here and looking is if you miss the sine of theta, you're also going to miss the cosecant of theta. So I'm going to take the cosecant of theta. I know it's the reciprocal of sine. Sine is opposite over hypotenuse, so hypotenuse over opposite, and that's what I got. Secant is adjacent over hypotenuse, so I'm just going to flip that over. 25 over 24 is the secant of theta, and the cotangent is opposite over adjacent, so 24 over 7. To check it out, example 1, same thing. You're doing sine, cosine, tangent, cosecant of theta, secant of theta, and cotangent of theta. Now, remember, simplest form, okay? Sine of theta. Now, notice your theta is in a different place. Don't get in a habit of thinking that theta is going to be in the same place. Up in example 1, theta is on the bottom. In the second example, theta is up in that top angle. So the sine of theta is opposite over hypotenuse, so 30 over 34. 2 goes into both of those, so 15 over 17 is how that simplifies out. I'm going to go ahead and do the cosecant. It's 17 over 15. Cosine is adjacent over hypotenuse, so 16 over 34. Reduce that fraction, 2 goes into 16 8 times, 2 goes into 34 17 times. The reciprocal is 17 over 8. I'm going to check my secant just to make sure. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so 34 over 16. 2 goes into 34 17 times, 2 goes into 16 8 times, so that is correct. The tangent of theta is opposite over adjacent, so 30 over 16, and that reduces to 15 over 8. So the cotangent of theta is 8 over 15. Now, when you were in geometry, you talked about a 30, 60, 90 triangle and a 45, 45, 90 triangle. And these triangles had certain sides that you talked about. And these are just things that you're going to have to memorize. So on a 30, 60, 90 triangle, the ratio, and so there's ratios to these triangles, and I'm just going to talk about the side lengths. When you have a 30, 60, 90 triangle, the side opposite the 30 degree is 1. The side opposite the 60 degree is a root 3, and the hypotenuse is a 2. And what that means is it's in a ratio of 1 to 2 to 3. Your 30 degree has the shortest side. The side opposite that 30 degree is the shortest side. So here my side lengths are 1, 2, and root 3. 1 is the smallest number, so it's opposite the smallest angle. 2 is bigger than root 3 because root 4 is equal to 2, and root 4 is bigger than root 3. So 2 is the bigger of the 3 numbers, so it's opposite. That side length of 2 is opposite the 90 degree angle, and then root 3 is opposite the 60. So the sine of 30 degrees, opposite over hypotenuse, 1/2. The cosine of 30 is adjacent over hypotenuse, so root 3 over 2. The tangent of 60 is opposite over adjacent. And notice what's going to happen here. You have 1 over root 3. Well, you can't leave a radical in the denominator. So you have to rationalize. You rationalize up and down by what's in your denominator. If I multiply root 3 times root 3, that gives me root 9. So that gets rid of that denominator, or gets rid of that radical in the denominator. Well, whatever you do to the denominator, you have to do to the numerator. So I'm going to multiply up and down by root 3. And if you'll notice, multiplying by root 3 divided by itself, all you're doing is really multiplying this fraction by a 1. That's not changing the value, it's just going to change the way it looks, and it's getting rid of that radical in the denominator. So multiplying straight across, 1 times root 3 is root 3. Root 3 times root 3 is root 9, which is 3. Keep in mind, radical, simplest radical form, no radical in the denominator. All right, the sine of 60, so here's 60 degrees. The sine is opposite over hypotenuse, root 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse, so 1/2. Tangent of 60 degrees is opposite over adjacent, so root 3 over 1, or just root 3. Simplest form, so I'm not going to put that over 1. And if you'll notice, sine of 30, cosine of 60 are both equivalent to 1/2. Sine of 60, cosine of 30 are both equivalent to root 3 over 2. Those are called cofunctions of complementary angles. 60 degrees and 30 degrees add up to be 90 degrees, so they're complementary angles. The sine of one angle and the cosine of the angle that adds to this angle to give you 90, the sine of one, cosine of the other, are always going to be equivalent answers. That's just a shortcut for you to kind of help you, where you can real quick know what an answer is, if you'll just remember that. All right, on my 45, 45, 90 triangle, those side lengths, if you'll notice, these angle measures are the same, so my leg lengths should also be the same. They're the ratio of 1 to 1, and the hypotenuse is the square root of 2. So the sine of 45, opposite over hypotenuse, 1 over root 2. Well, you can't have a radical in the denominator, so I'm going to rationalize. 1 times root 2 is root 2, over root 2 times root 2 is root 4, which is a 2. So the sine of 45 degrees is the square root of 2 over 2. Notice about the cosine of 45. Cosine of 45 is also 1 over root 2. Can't leave it like that. I've got to rationalize. So that final answer is root 2 over 2. Now notice, 45 plus 45 is 90. Cofunctions of complementary angles. The sine of one angle, cosine of the other one, should be the same answer. So the sine of 45, cosine of 45 are both equivalent to root 2 over 2. The tangent of 45, opposite over adjacent, 1 over 1, which is 1. This is a very important chart for you to learn. These 9 trig values are very, very important. You have to know these 9 trig values to be able to fill in your unit circle. And we're going to do that starting on Thursday.